Actually, it's 4 after some modification happened. What is this stages? Solid, liquid, gas. This is a default, correct? But
Yes.
actually, we add black for this boss. Yeah. Solid, as you see here, particles all connected together. Liquid, slightly far. Gas, very far between the particles. And then plasma. Smaller formation for each one. Solid is definite shape, but others, liquid, gas, and plasma is not definite shape. Solid and liquid have a definite volume, but gas and plasma, no definite volume. This is simple information. What is the important information for us? The main important point, energy increase from the solid side to the plasma side. So in the gas, if the this material in gas state, so the energy for this material, it is higher than from solid state. So the energy increase from the solid to plasma. Clear? The energy for the material, it is increased from the solid to plasma. Fluid is a substance that here with us.
Has the same shear stress.
No suggestion? No one have idea?
Okay.
A. Actually, the fluid is a substance that can't be remain at rest under action of any shear force. Okay. Fluid is a substance which offers no resistance to change of pressure,
shape.
not A. I see one give me answer in chat is correct. C. Shape. Change of shape. No, change of shape. Resistance to change of shape.
Yeah, I got it.
CM.
We talk about for the units last session and the importance for this part for units. Here's this simple points, just length, mass, time, temperature. Okay, it's not at all. We will see other units during the solving problem, like the importance, like for pressure, like density, like mass, and so on. Okay, but here's just a sample for this one. Okay, focus for these definitions. Velocity. The definition of the velocity, rate of distance, rate of change of distance. Okay. Definition is important. Why?
Yeah.
We will see some problems solved by the definition, by these simple equations. Okay. Maybe in example, for velocity, for example, solved by the initial definition for, like this, dx by dt, the change of distance with time, rate of change of distance. Sound, please. Close the mic if you have another talking. Okay, I just opened mic to sharing with me. Discussion, just close the mic, please. So the velocity here is rate of change of distance, dx by dt. The unit here is meter per second. Other unit for bridge, it is feet per second, feet per second. Okay. Acceleration is meter per second square, meter per second square. Rate of change of velocity, rate of change of velocity. And the other unit is feet per second square, feet per second square. During solving for some problems in British, we will see some tricks for units and the conversion of units. Even if it is British, an exam, the examiner prefer to bring length in inch unit, and regular problems and units solved by feet. And both, as you see, is British. So you found some is inch, some is feet. Be careful for this trick, because once you see this British, and I will continue by British solving, so I put the units as it is and so on. No, be careful, please. Some units is inch, some unit is feet, and some units is including the unit itself. For example, for pressure, PSI, pound per square inch. But almost all in the equations, it is units of related to feet. So we need to change this square inch to square feet. Okay, be careful for these small tricks. We will make training for that during some problems. Okay. Force is mass times acceleration. Mass times acceleration. If this acceleration is related to gravitational acceleration, so this mass is represent weight. Represent what? Represent weight. And the unit for this one is kilogram meter per second square, which is Newton. This weight is mg. Mass times gravitational acceleration. Here this g is 9.81. But this for SI unit, which is meter per second square. This is a famous number. So we need to save another one, is 32.2 feet per second square. Okay? Work. What is the equation and definition for the work? Work is force times distance. So if you apply any force, okay, if you apply a force on the table like this, and the table it's not moving, but already I apply a force for this table, now we obtain work or no? Hello?
No work.
Was in area.
No work.
Yes.
Many question coming with different shapes in exam related for this definition. The concept of work, force times distance. Okay, in the fluid mechanics, sometimes the equation of the work is related for the pressure times volume, or change of volume. So if there is no any change in the volume in the fluid, so there is no work. Okay, same like this concept, force times distance. There is no distance happen, whatever you apply force or not, but there is no distance happen. Okay, so there is no work. Power, it is a rate of the work, The work unit is joule. The power is joule per second, watt. Mass density, it is rho, which is equal to mass divided by volume. Kilogram per meter cube. Okay, this is density. This density, it is a property for all materials, like water have a density, oil have a density, anything have a density. Okay, different fluids or different materials have a density, and we have table for these densities. Okay, and this density, it is a property. It means it's constant at standard pressure and temperature, STP, standard pressure and temperature. Okay, if the temperature and the pressure change, so density is a change. But if the temperature and the pressure it's constant, this is standard conditions, so the density for this material is not a change, it's a property. Specific weight is gamma. This gamma, it is a property same like density, exactly, not different. The only change, the density is alone just multiplied by the gravitational acceleration, we obtain specific weight. This is important, one of the important properties, gamma. Okay, actually mainly for pressure is equal rho g h, correct?
Pressure.
This is famous equation for the pressure, but we have another
Yes.
for pressure, gamma h. So if this given direct gamma, so what we need only gamma multiply h, we obtain direct for a pressure, because gamma is equal to rho g. Okay, and then for this one, Newton per meter cube, not kilogram, Newton per meter cube. Okay, so the mass density it is represented for bound mass, but the specific weight it is represented for bound force. Okay, this as a British unit. Because the equivalent of Newton in the British is bound force. A specific gravity. One of the famous property is coming in the exam. A specific gravity. What is the specific gravity? S, G, whatever. Name specific gravity. Specific gravity, it is a ratio between the specific weight for the fluid you need divided by a reference. We can keep it as a reference. What is this reference? Gamma for the water. Gamma for the water. This one. Gamma for the required fluid, which is half the specific gravity given, divided by gamma water. And this is also equivalent to rho for the fluid also, divided by rho water. Same equivalent. Why? Because gamma, when we substitute it to the original rho g, and this one rho g, we can cancel g with g, and the remaining rho divided by rho. Example for this one, I give you SG, I have oil used for this cycle for blah, 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 and SG is equal to 0.8 for the oil. Okay, so I can't use SG direct in the equation which have rho or have gamma direct like this. So what we need to change this one to represent or get density for the oil or gamma specific weight for the oil. How to get it that? Should be know the density for the water, for example, is 10 to the power 3 or 1000 kilogram per meter cube. So if I need density for the oil, which is the type of the fluid for the problem, oil, what I need to use it in the equation, equal what? How to get it this one? From SG. SG equal what? Ratio between the density for this one, which is oil, divided by the density for the water. So it is equal to rho oil
800.
divided by rho water. So it's equal to rho oil is equal to what? Rho water multiply SG, which is equal 10 to the power 3 multiply 0.8 equal 800 kilogram per meter cube. Be careful for this one coming in the trick in the problem is coming a lot. Many problems coming SG, not coming direct density. If the fluid, it not a water. If the water, it is going to get raw water direct. Okay. If you want to play more, give SG for the fluid and the fluid is water. SG is equal 1, so it represents raw water direct. But normally for SG, not a water, is given for the problem. It's not a water given SG, not give raw or gamma direct. He play with this one. Okay. Why? Because if you don't know the meaning of SG and something like this, you're just going to take rho of water or gamma for water given and apply for the equation and get the answer direct, no problem. You tell me, but if I solve it like this, I can't to get the answer in the choices. No. My experience for the exam, what you think for all options, you found in the choices. If you solve it by raw water direct, you found your answer in the choices. If you solve it by another thing, it's not correct, also you found in the choice, and so on. Okay, be careful for that. He play a lot for this tricks for the exam, because as you know, all engineers, I can try this to check, this to check, this to check. I make it like this for some problem in the exam, but when I check all given, for example, extra given, but when I need to check which is matched with the answer, I check 3. I need 1 actually, but when I check 3 which is matched with the choices, I found the 3 choices in the answer. Okay, clear?
Yes, boss.
Okay. SG, what is unit for SG?
No unit.
Dimensionless. Yes, no units. Fluid properties, one of this one is bulk modulus of elasticity. What is meaning of bulk modulus of elasticity? When we hear about for
delta P by delta V.
Bulk modulus of elasticity.
Of elasticity, bulk modulus of elasticity. Bulk modulus of elasticity is a property related to the change of pressure to the change in volume. A change of pressure to the change of volume. What's the meaning of that? For example, I have two material, okay, two fluid. These two fluid, I apply with the same, no, keep it the other way, is better to understand. I make the same change in the volume for both. I make the same change in volume for both. This one, the change of volume, X. And this one, this change of volume, X also. It means the percentage of the change of volume here is the same other one. But what I need for the pressure here to make this change is higher than this pressure. You understand me? So I make the same change for two fluids, the same change happen, but I apply the pressure here higher than the pressure there. So from your side, which one is easier to make this change of volume? Which one is easier to make a press to change of volume? Which is need high pressure or low pressure?
Easier low pressure.
Easier low pressure. This is what he show or represent bulk modulus of elasticity. Give each fluid value. This value it represent this value is as a property for this value, for this material, okay? And you give this material with this number, other one, this number. It means I need this amount of pressure to make a change of unit of volume, for example. This one of the pressure required to make a change for unit of volume, and so on. So when the number of bulk modulus decrease or increase, this easier to press. Which number? When the number of bulk modulus of elasticity is higher or lower, this indicate easier material to press.
Higher.
Higher value.
A higher value is easier to change.
Higher value means you need high pressure.
High pressure is put that material that only change the volume. Correct?
High pressure is what?
High pressure is put that fluid that is, volume is also changed. Maybe that one is increase.
But higher value, it means we need high pressure, high force, okay,
yeah,
to make the same change. If we make a comparison between these two, both have same change, okay,
yeah.
But this one need to change, to make this change to Y.
Yeah, pressure.
This one is 1.5 Y. So which is one is easier to press?
With the low bulk modulus of elasticity.
Bulk modulus of elasticity is low.
Low.
So because a bulk modulus of elasticity, it is going direct to pressure. Okay. Also, the unit of bulk modulus of elasticity, it is a unit of pressure. How come? Because this one is a property related to change of pressure to change of volume. We put the volume in the shape of dimensionless. We will see now. See the equation. E is the represent for bulk modulus of elasticity is equal to the change of pressure to the change of volume to the total volume. We put it the volume is a percentage. It means 10% of the total volume, 15% of the total volume. It's okay. So the denominator is dimensionless. So the bulk modulus of elasticity is direct the same unit of
pressure.
the pressure.
Okay.
See this question.
Pardon me, sir. Hello.
Hello.
Ethyl alcohol is easier.
Hey,
Ethyl
Ethyl
alcohol.
alcohol.
Can you please repeat what's bulk modulus of elasticity?
Again. Your voice is not clear, please. Can you tell me again?
Can you please repeat what's bulk modulus of elasticity again, please?
Okay. Bulk modulus of elasticity, it represents the change of pressure to the change of volume. So first, this is the equation here, the change of pressure to the change of volume, but we put the change of volume in the dimensionless shape, dV by V, percentage of the change of volume. Okay?
So what is minus sign in front of that?
Because this opposite together, pressure and volume.
Oh, so it will come in negative value.
Negative, it's cancelled together.
Okay.
So we have this material or fluid, another fluid. Okay? These two
Okay,
fluids. Here happen change of volume.
Okay, sir.
I make it the same change of volume here.
Okay.
For example, this 10%, this also 10%. Okay?
Okay.
But what I need here, 10 kilopascal. But what I need to make this 10% of the change of volume, 30 kilopascal. So which one is easier to make this press?
This one, sir, 10 kilopascal.
10 kilopascal, just need to small value for the
Of
pressure.
course. Yeah.
If we divide
Of
10 divided by 10% and 30 divided by 10%, so we obtain also the lower value, which have 10 kilopascal, which represent bulk modulus of elasticity now. So low value or low pressure is represent low bulk of modulus of elasticity.
Okay.
And the opposite, low bulk modulus of elasticity, it represent easier material.
So the unit is Newton per meter square?
Newton per meter square, which is Pascal.
Newton per meter square for a bulk mod. The unit of bulk module is Newton per meter square, right, sir?
Yes, the same unit of pressure, Pascal.
Sir, it can be kg plus kg per centimeter square also.
Kg by what?
Kg per centimeter square.
Kg?
Kg per centimeter square.
No.
Kg per centimeter square?
Centimeter square, yes.
Like this?
Yeah, like this.
How come?
This is a unit of pressure, sir.
This unit of pressure?
This is a unit of pressure. Like
If
1
this
bar is
unit
equal.
My question, if this unit of pressure, no problem.
Meter square.
But to be sure for that, I need to check the Newton to be going to the original units like this here. Where is this one? Here, like this. This is the force here. Kilogram per meter second square.
It's kilogram
This is the force
per meter per
so
second.
the pressure.
Square, okay.
This is the Newton actually, correct?
Right, sir.
So divided by area, which is pressure.
Yeah, right.
Correct? So
correct.
It's like this, it's okay. Okay?
Okay, sir.
Whatever the type of the pressure, it is the same pressure, of, same unit of pressure. This question clear now?
Yeah.
Sir, but water is an incompressible liquid, right?
Water is incompressible. We will see this later, yes.
So this question itself says that ethyl alcohol is easy.
Yeah, you will see this classification for the fluid, all classification at the beginning of the next session. All classification, steady, unsteady, uniform, non-uniform, compressible, incompressible, viscous, inviscid, all these types will classify at the beginning of the next session, inshallah. Viscosity. Actually, viscosity, it is important. Theoretically, definition, units, numerical, so equation is important. What else? I think so. That's it. So at all, it is important. Viscosity definition, it is a fluid property represents the resistance of the fluid to deformation by shear stress. Again, it's a property, first thing. So we can check for each fluid, we have value for viscosity. But this property, it represents what? Resistance of the fluid, resistance of the fluid. If you imagine a fluid is a layer, some mobiles like this, and we sliding this mobile above each others, what we will see, the first one is not the same like below, it's not the same like below, and so on and so on. We have shift between one and the other, one and the other, one and the other. First one, which is free one, it is higher velocity, and go through down, this velocity is decrease according to the resistance between the layers till we reach to the stationary one, which is almost zero, correct? This actually related to viscosity property, and they create for this shear stress. So here's the equation used, it is shear stress equation, this equation. What does this equation include? Tau, which is shear stress. I focus for the each term name because it is important. Shear stress. This one is mu, which is viscosity or dynamic viscosity or absolute viscosity, all the same name. Last one is du by dy or delta u by delta y. Du by dy as a regular equation, delta u by dy by delta y in a special case which is linear, if the velocity gradient is linear. What is name of delta u by delta y or du by dy? This one is name have velocity gradient, both. Okay. Focus on small
dimension.
tricks. Velocity gradient. Have another name? Yes. Also coming in the exam for just for question theoretical. Shear strain. Rate of shear strain. Again, rate of
The voice is breaking.
-1. The unit of tau is the same unit of pressure. Newton per meter square.
Can you repeat? Your voice was breaking.
Repeat?
Yeah.
Yes, sir. Your voice was. We can.
Yeah.
Voices have a problem?
Yeah.
Yes.
Yes,
Yeah.
We need to have slow.
Noise.
Okay. Tau equal to mu delta u by delta y. Okay?
Yeah.
Okay.
Tau is shear stress, same unit of pressure, which is Pascal, Newton per meter square, whatever. Mu is viscosity. Okay? Viscosity, dynamic viscosity, absolute viscosity, Newton second per meter square. Newton second per meter square. And we have another one is very famous coming in the exam is poise. Poise,
Centipoise.
Poise is equal 0.1 Newton second per meter square. The convert is important to coming in the exam. I bring one problem like this maybe in exam 5, exam 6, something like this. Delta U by delta Y is velocity gradient or rate of shear strain. Unit is second minus 1. Okay. Regular equation is tau equal mu du by dy. Okay. But in this case, as a general case, this used to solve the equation. This not linear equation like parabola equation, something like this. So we need differentiation direct, going to differentiation time. But in exam, normally it's coming simple. This part is going to be coming direct, or if it's coming, he presents a linear relation between these two. Because this one we're going to a linear relation is easy. What is easy? Delta U, it means U2 minus U1 and delta y, it means y2 minus y1. If you have 1, 2, 3, for example, you can get it the fourth one. No need for any differentiation. Okay, so this simplest equation, simplest form, this one is a regular one. Okay, this clear?
Oh, yeah.
Back again for the presentation. As you see here, the velocity here contact with this point is equal to 0, which is fixed one, stationary, and the free one is the same velocity with the flow velocity, and in between the velocity is decreased according to the velocity gradient. If like this velocity gradient is decreased linearly, we can use the delta u by delta y. It is represent velocity gradient. Kinematic viscosity. Kinematic viscosity. What is kinematic viscosity? First symbol is nu, not mu. Okay, nu is kinematic viscosity and coming in exam a lot. For example, Reynolds number. The famous equation for Reynolds number, as you know, rho Vd over mu, correct? This famous equation comes.
Pardon?
But actually, in the exam, in the Reynolds number definition, you know Reynolds number? Reynolds number, which is represent the flow is laminar turbulent.
Oh, right.
The equation used for that, rho Vd over mu. Okay, this is a regular equation, but in the exam, it's coming a lot in the exam. Vd over nu. So what is nu here? Nu, it is a ratio or normalized ratio between viscosity and density. It is a viscosity for the material or the fluid normalized by density. So viscosity, it is a property for the material. Density, it is a property for the material. When you divide density by density, property by property, we obtain another property. Kinematic viscosity also, it's a property. So viscosity is a property, density is a property, kinematic viscosity is a property. And the kinematic viscosity, it is equal to mu, which is the viscosity, divided by rho, which is density. This one. Mu equal mu by rho. Normally, it is not coming like this to apply for nu equal mu over rho, but if it is coming like Reynolds number, for example, and they give this equation given, okay? Don't surprise for this equation. This is correct. Vd over nu. It's not incorrect or something like this. No, this is correct because the nu, it is equal to mu divided by rho. What is unit for this one? Meter square per second. Meter square per second. Any question for viscosity property or anything like this, kinematic viscosity or anything related for that? Hello? Hello?
Yes, doctor.
Yeah, any question for the viscosity part?
It's fine.
Okay. Read first, please, and we will continue.
Excuse me, there are lots of background voice coming around. Lots of disturbance, background noise. Please, guys, make sure there is no background noise from your wherever you are sitting in here.
Almost now. Okay, finish reading. You can start. Okay, I will open whiteboard. Here we talk about for the 2 plates. Distance between these 2 plates is 1 centimeter. Dimension for these plates. It's 20, 20, and 1 centimeter. We have force applied for this plate, and the other one is stationary. This force is equal to 5 Newton. The required is the velocity at 0.5 centimeter and 1 or 0, 1, I think so. 1 centimeter from the upper surface of the lower plate. So we measure from here 0.5 centimeter, and we measure from here 1 centimeter, which is contact with the upper plate. Velocity profile is something like this, linear, assume linear. So we have something like this. We need this velocity, and we need this velocity. At the beginning, what is the equation? We can change color here to this green. Tau is equal to mu delta U by delta Y.
Delta Y.
Actually, mu is equal what? 1 boys. Given mu is equal 1 boys. So 1 boys is equal to 0.1 Newton per second. What is it? Newton meter per second square, I think so. I don't remember. Newton second per meter square. Newton second per meter square. Newton second per meter square. So we have mu. I need U required. I need U at Y equal 0.5. I need U at Y equal 1 centimeter. Question for exam, it's not coming like this with many questions, just ask for one point, okay? So here, to solve and get it U, it is including this one, this part, delta U by delta Y, correct? So at least other should be given. Mu is given, but tau it's not given direct. It's given, but indirect. What means that? Actually, the definition of stress, what's the definition of stress? Force divided by area. So this tau is equal to what? Force divided by area. Force we have.
Like Newton.
Area we have. Which area? We have 3 dimensions, 20, 20, and 1 centimeter. Actually, shear stress, it is related to the contact area. Related to what? Contact area. Where does this shear happen? Between layers. So this contact between the layer and the blade itself. Contact between layer and the blade. So the area is what?
20 to 20. 40 centimeter square.
Yes. So tau equal force divided by area, which is equal 5 Newton divided by 0.2 multiply 0.2, which is equal to 1 to 5. I think so. I think so. You can check quickly.
125.
1 to 5. That's correct. So this one is equal 1 to 5 Pascal. It means we're going to substitute for the original equation. 1 to 5 Pascal is equal to mu, which is 0.1 Newton second per meter square, multiply delta U, which is what? U2 minus U1. Delta Y, Y2 minus
Y2 minus Y1.
So if I need to get it the first unknown, U at Y equal 0.5 centimeter, So we need, for example, this U2 at
0.
0.5. In this case, we need to have this one, correct? So search here for the problem itself. I need Y at U or U at Y, whatever.
0.
Yes.
0, sir.
This point.
0.
This is considered as initial point, which is Y
Zero.
equals 0, and the velocity is equal what?
0.
0 also. So this I consider as a 1 and 1. So this one,
Okay.
we can put it 1, a 0, sorry. And this one, put it 0. We can get here and substitute direct to complete the equation. 1 to 5 equal 0.1
0.5.
U2, which is required, and divided by 0.005. Like this?
0.0.
Correct, like this?
Sir, how y2 becomes 0.002, 005?
No, this is y2. This 0.5 centimeter, I convert to meter. I convert